Welcome to what I believe is our 34th episode of Ideas and Lives. This is a webcast and podcast hosted by my buddy and friend Svi Bodhi and I. I'm Bob Lerman. I'm a social policy economist. And Svi, introduce yourself.
I am a financial economist, retired after teaching for 40 years at Boston University School of Management. And as Bob has said, co-host of these fascinating interviews with people like Chris, who happens to not only be a pioneering computer scientist, but also my neighbor.
Right. So
Chris,
why don't you introduce yourself and we'll get started.
Okay. Hi, my name is Chris Reeve. As V pointed out, I am his neighbor, and I spent my entire career as a computer scientist, software engineer. Unlike Zvi and Bob, I am not an economist except by hobby as opposed to profession or anything like that. And my goal here, as I discussed with Zvi, is that I feel like I've lived through a major portion of the quote computer revolution. And I wanted to share with the audience what that really means and what I went through.
Great. Well, we'll definitely get to that. But in the meantime, we generally start with your early life.
Okay.
Tell us where you grew up.
That has an interesting component of it in and of itself. I was born in London, England, of British parents. When I was 8 years old, my father's company decided it wanted to expand into the US, and he was invited to start that branch of the company in New York, actually on Wall Street. So the entire family emigrated from the UK to the US in June of 1953. And I don't know if this will be seeable. Can you see that photo?
It's a little blurry to me, but
yeah, a little blurry to me too.
So maybe we'll
hold it at a distance. Let's see.
Basically, what it is a picture of my family on the deck of the Queen Elizabeth ocean liner.
Wow.
Way from the UK to the US. Maybe I'll try and scan it in. And unfortunately,
did you know? Yeah, we'll include it. Did you know, and did your father know that this was going to be a permanent shift in residence?
That has an interesting. Yeah, I'll get to that. So it was not initially going to be a permanent presence. So I came and I started the third grade here in the US. We settled in Larchmont, New York, which is a suburb in Westchester County. My parents selected it because it had the best school system around, which was the Mamaroneck High School or Mamaroneck School District. As I also mentioned to Zvi earlier, I managed to lose my English accent in record time because I really wanted to fit in with all the other kids, and they always gave me strange looks when I spoke with a British accent. So that was 53. In 1957, the company told my father it was time to come back to the UK. And there's a story here. We decided to take a family trip, me, my older brother, and my younger sister, a driving trip from New York down to Florida, stopping at various places. It was the first time I'd ever seen things like water fountains that said colored only and white only and things like that.
Yeah.
But one of the interesting things is we visited my paternal grandfather, who had actually left my maternal grandmother. So this was the first time I'd ever met him. And he asked me what I wanted to do when I grow up. And I said, I want to be an engineer, which to my mind meant driving a train at that point. But he said, if you want to be an engineer, there's only one college you should go to, and that's MIT. So my father decided that he didn't want to go back to the UK. Both of my parents really liked it in the US, so he just got a different job, and we stayed on. And lo and behold, 10 years after 1953, which is when we arrived in the US, I set out in 1963 to Cambridge, Massachusetts to become a freshman at MIT.
Wow.
So that's the very early part of my life.
So yeah, were you confident you'd get in?
No, but interestingly enough, a couple of facts. 6 people out of my high school class got into MIT, which was a record that year. And it turned out, I found out much later, like at my 50th reunion, that back then, MIT selected more like 1 out of every 2 applicants as opposed to like 1 out of every 10 or something like now. Because those days, there were only primarily men. There were very few women. So that cut down the pool. And in those days, they weren't very interested in whether you could read or speak English. They just wanted to know, could you do good math and science? And I had exceptionally good grades in those. I didn't, I was mediocre in the others, but they didn't care. So I was still surprised when I got in, but happy. And
Yeah.
so
tell us about your college experience at
so
MIT.
Yeah, so because my high school had good AP courses and everything, my first year at MIT, I did very well. And I also discovered that, well, I needed to get a part-time job because my parents couldn't afford the whole cost of MIT. So my first job I got was in some radiation or something lab where I was looking at an oscilloscope with particle traces, and I had to put a cursor on the screen at where these traces were, and it would print out punch cards for a computer. It would generate punch cards. But I did learn that the way to get an interesting and good job at MIT was to learn to program. So my second semester of my freshman year, I took the introduction to computer programming. And it was taught by Marvin Minsky, who you may or may not have.
Yeah,
pioneer of artificial. But besides being a pioneer of artificial intelligence, he also had to teach freshmen every now and then. So I had the privilege of working with him. And the first program we had to write was called SumDiv, and it was It would give you an integer and you had to generate the sum of all the numbers that divided evenly into that integer, except the number itself. And the way you did it then, you punch cards, there are card punch machines around, you submitted them, and then the next morning, you got this output from the computer because they ran it overnight. And my first program gave me an error and I couldn't see what was wrong. And I went storming into the TA's office and said, "This is wrong." And the TA said, integer is INTEGER, not INTIGER. So I learned very quickly, A, not to be overconfident about some of the errors that the computer might have made. B, that computers are very picky. They really don't like you to misspell a word.
Well, it was an error you made, right, in spelling.
Yeah, right. That's what I mean.
That's it.
Well, these days, computers correct your spelling.
Yeah,
but they
that's
didn't
true.
do that with punch cards.
They didn't do that then, yes.
Yeah. So anyhow, I fixed that and then the program worked fine. And the other good thing about this course was and later in the course, they got special permission for us to use this magic new thing called time sharing, where there were teletypes and IBM Selectric terminals connected directly to the computer and you could type in the program. So I got to experiment with time sharing, which was very exciting because it was a new technology and MIT was one of the pioneers in that field.
Now, before that, did you have to always submit programs on punch cards?
Yep. And another interesting punch card story is with a friend of mine, we entered a contest we found somewhere, which we thought was amenable to a computer program solving it. So we wrote a program, I wrote part of it. And one place I had something that said, printed out, your program doesn't work. And then it was supposed to exit, but I forgot to put the exit in. So the next morning, instead of getting one piece of paper, I got an entire box of paper from the computer department, every line saying your program doesn't work.
Well, it's better than having to put on the blackboard 100 times writing.
Yeah, right, exactly. I will behave in class. I will behave in exactly. That's what it felt like. But
well, the computer did it, so it wasn't so hard for you. So you that sort of stirred your interest more generally in computers.
Yeah, and then
going into that field.
Well, then
wasn't really a field then, was it?
No, it wasn't a field. It was part of electrical engineering. But the goal, as I mentioned earlier, was to try and get a better paying, a more interesting part-time job. And I got a job with a guy in the political science department who was from Venezuela, and he was analyzing data that he brought with him from Venezuela. And so I was writing programs for that. And interestingly enough, big data then meant it was a giant box of hundreds and hundreds of punch cards, which had to be read into the program. But anyhow, I worked with that professor for through my entire undergraduate career. And then one of the other things is because I did so well my first term at MIT, I got into this special program of getting a bachelor's and master's essentially together. So I didn't have to really apply for a graduate. So I got a master's, and one of these things that probably was life-changing that I didn't realize at the time is my the political science department traded me to another department. It's kind of like baseball, you trade a player anyhow, where I got to actually work on the inner guts of the time sharing system. So it was at this research lab at MIT called Project Mac.
Is it called machine language a bit, or there used to be a term called complete?
Yeah, well,
with the zeros.
Yeah, there's either high level language, which in fact we used a language called MAD, MAD, standing for Michigan Algorithm Decoder. And the more popular language around those days was Fortran, which is Fortran. Still, but MIT always likes to be different, so they had to have a different language. But in working on the CTSS system, it was in, as you say, machine language, or so you actually write out the instructions exactly that the computer was going to execute. So I got hired. I went to the head of Project Mac, and he gave me this piece of paper folded in half and said, "This is your password for a special account that allows you to get into the system." It was almost like read it and chew it up and swallow it. It was so secretive.
And Project Mac, which was the way it was referred to at MIT, was man and computer.
Or machine-aided cognition or something. It had various, no one ever settled on what it really meant, but there were several different, So my job at that point was to interface the CTSS system to a graphics terminal, which had not been done. Everyone was using just paper, either via teletypes or IBM Selectrics. So I worked on this project, and one of the interesting things is the group I was in was assigned a certain number of minutes of computation time per month. But early on, we discovered, since we could get into the system, we could patch the place that said how much we'd use. So every time we got close to the end, we patched it to 0. So really the first, quote, hack, unquote, on a system that I ever participated in.
Wow.
Were you discovered? Was your deed ever discovered?
Nope. No one checked on it. So no, it was never discovered. So.
Yeah, well, sort of that used to be a thing, to rent computer time.
Yeah, exactly, because it would cost a lot of money per minute of computation time on these were giant IBM machines that the system ran on. And so, they wanted to account for every, and then they would charge that to some government contract.
Now, my recollection is that soon after that, you had the advent of digital equipment. The company.
That was exactly what happened. At the end of when I got my master's degree, which was in the fall of '68, my master's degree involved some of the technology I developed to get this graphics display to work on CTSS. So after that, I was offered a job in the same lab. Now, '68 was at the height of the draft for Vietnam, and I could get a you are critical to the national security working here, so you can't draft this guy. So that seemed like a good deal. And plus it was interesting work to do. But very shortly after is when they got a deck machine, as you point out. That was the kind of the research machine that people like to use. Yeah. So, so yeah, after I started working, this guy, JCR Licklider, who in some sense is if there's anyone who, quote, created the internet, he was probably as close as could be, because he wrote a paper early on in the very early 60s describing how computers were going to become used as communications devices, and that people would be able to write papers and send them back and forth between computers and edit. And it was like, wow, that was way in the future. But one of the projects he got started was, in fact, the ARPANET, which was the precursor to the internet. And so we were working on this very, a lot of forward-looking research. And our lab had one of the first computers that was connected up to the ARPANET.
And then there was another term which I was familiar with because I used it, called BitNet. Had you heard of BitNet?
I've definitely heard of BitNet. I think that was a bit later. I think ARPANET came sort of online in the mid-70s. Yeah, but yeah,
BitNet by the early 80s, BitNet was there.
Okay.
But was that the ARPANET, was that also related to the Defense Department?
Oh, yeah. Yeah. ARPA was the funding organization, Advanced Research Projects.
Yeah.
Or whatever. And these days it's usually referred as DARPA, Defense Event. Those days, for some reason, it was just ARPA. Yeah, it was all funded based on that this would be very useful for the military to be able to coordinate lots of things and send data back and forth and things like that. So that's why it got funded, and that's why it happened.
So you stayed at MIT basically in the lab.
Yeah, so basically I got a job that my title was something like research associate, and I worked there until about 1985. From 1970 to 1985.
Long time.
I did go 3 years in the middle there. I went and worked for a private company for a while, but then came back to MIT. So one of the things that about working there was that we had incredible flexibility in what we did. The people running the group, just something interests you, work on it. There were some general guidelines, but so I and a few other people developed this computer language, a high-level language called Muddle, MUDDLE. And later we had to rename it to MDL because the research guy said he felt embarrassed talking to the defense people about a language called Muddle. So, and we all internally still called it Muddle, but anyhow. But one of the things that happened, some of the students at the lab I was working at found this game called Adventure, which was what's called a text game where you type in "go north" and it says you are now in a field. There's a house in front of you, and you could say enter house. So these guys said, "Oh, we can do better than that. We can make a much better game." So using Muddle, the language I worked on, they developed this game called Zork, Z-O-R-K. And it was much more flexible adventure. You could have complicated sentences like pick up the red book and the blue pencil, and it would understand that, whereas the original adventure only took 2-word sentences. And then because it was on the ARPANET, other researchers and people at other colleges were able to run it. But about 1980, some of us decided, well, we should see if we can make this game smaller, because it was running on this giant DEC mainframe, and sell it as a product on PCs. So we formed a company called Infocom, which made text adventure games. And Zork, which had already been out all over the place on the ARPANET, was our first product. And it ran on the Apple II computer and on the TRS-80, which was the Radio Shack computer initially. But shortly thereafter, we also ported it to the IBM PC, which came along shortly thereafter.
Yeah. Well, I had an Osborne computer.
That's another, yeah.
One of the,
well, one of the things,
I don't know whether I never got to Zork, but
one of the things about Infocom is, yeah, back then there were a bunch of different. There was Atari, there was Radio Shack, there was Osborne, there was IBM, so Commodore. So the technology we used made it very easy to let the game run on all these different systems without doing a whole lot of rewriting work. So in fact, later,
before you talk about, can you tell me how people started thinking about a personal computer? Because you went from this lab,
no, you're right,
deck, very detailed, and now we're turning to something that an individual could actually buy and use.
Before that, there had been some kind of kits that you could buy and build your own computer. And that's what kind of got people thinking about, home computers. And by the time we got to thinking about starting the company, the two that I mentioned initially, the TRS-80 and the Apple II, were out and very popular. People were buying them all over the place. So we sort of just jumped on it and try and to quote catch the wave, as it were, including, so when the Apple Mac first came out in the 80s, I don't remember the exact
84.
That's right. Is that the famous ad with the
the famous ad in
but immediately when it came out, all of our titles ran on the Mac right away, because we had a Mac in advance and we just wrote a little bit of software to support our games, and they all worked immediately when the Mac was released, which was very very good. The success of Infocom and those text games was really because at that point, graphics on computers was very rudimentary. You couldn't get very good pictures, and our selling point was the best graphics are the graphics in your mind. So that's how we. Now, unfortunately, graphics got better and better. Therefore, the popularity of text adventure games started to decrease. But and we eventually decided that there was about 30,000 fanatics out there who would always buy our games, but that didn't generate enough revenue to support writing the games. So Infocom sort of eventually in about 1986, we sold ourselves to Activision because we were essentially going to go out of business if someone didn't pick us up. And shortly thereafter, I left the company because they didn't seem really that interested in what we were doing, and the Infocom stuff sort of faded away in about 1989, I would say. Yeah.
So where did you go?
So my next adventure was in the world of supercomputers. So supercomputers mean very fast, powerful computers. And one of the biggest customers for supercomputers those days was the Defense Department, because they used supercomputers to simulate atomic bombs. So they didn't have to actually explode an atomic bomb to do a lot of research on what would happen. So I joined a company called Kendall Square Research, which built this very interesting supercomputer. And I had kind of, through my work on model and other stuff, kind of pushed myself to being a compiler guy. So I like to write compilers. So I worked on you would give it a program and it would produce code for this very specialized supercomputer.
So maybe you tell, first of all, Kendall Square, for those that don't know, it's right next to MIT.
Yeah.
But tell us what a compiler is.
Okay. Well, we talked about early on, I mentioned MAD was the language we were using when I first went to MIT, and you mentioned Fortran, which everyone used. So the thing is, those are high-level languages, and a compiler is a piece of code which reads a program in a high-level language and translates it into machine instructions. And the more complicated computers get, the more complicated the memory system, there's a lot of optimization that has to go on to get efficient code out of a compiler. So, and that's what I was doing at Kendall Square. And in fact, there was a sort of a test suite that supercomputers used to see, how well they performed. And for a while, I was essentially told by my management, your group has to get a certain percent improvement on this test suite every month. You have to come back and say, we got it running this fast. We got it running. So it was pretty high pressure, but we more or less succeeded. The problem was, unfortunately for me, some of the higher executives were sort of fiddling the books a bit. And what they were doing were, as an example, they sold a computer to Cornell, but they also gave them a letter saying, we promise we'll take back the computer and give you your money back if you don't like it. But then they would say that money was revenue. Well, you can't say it's revenue if they can at any time decide, nah, we don't like this. And so anyhow, so for a number of years, they'd had this one auditor who wasn't all that careful, and they didn't seem to notice anything. But then they had a different guy it was Arthur Anderson was doing the auditing, and the different guy was a little more, dug a little deeper into what was going on, and he sort of figured out that, yeah, this isn't working very well. So they tried to find funding elsewhere, but were unsuccessful. So the company ultimately went out of business. But
did the management have any penalty, like going to jail, or was it just
I think they got fined. I don't think anyone went to jail. But they certainly were fined, and
how were the computers that you made? Were those good ones?
Oh, the machine was it was a very unique technology, which essentially, so one of the goals of, besides being fast, is also being able to do parallel processing, which means that you have multiple processors working simultaneously. And if you think about a loop, says for I equals 1 to n, do this computation. Unless each computation depends on a previous one, if they're independent, you can split that up into however many computers. So if n is 1,000 and you have 10 processors, you can say run 100 on each one of the 10. It'll run essentially 10 times faster than if you if you ran it sequentially on one machine. So parallel processing was definitely a thing that we were exploiting, and as were other companies. I think really the only survival of supercomputer world was Cray, and you've probably heard of Cray Computer.
Yeah, Cray.
Yeah, Seymour Cray, I think, is the guy who founded it. But they had very fast computers, and they were the first in the game. And I think there were a lot of other startups around Massachusetts even that failed essentially, and partly because the end of the Cold War, the interest in simulating atomic bombs, went down quite a bit. So
maybe there's a resurgence now. I don't know.
Yeah, I wouldn't be surprised. In fact, yeah.
Iran is probably trying to buy one.
So
anyway, so from there, so now you've got two companies that you work for. You had interesting jobs, but ultimately both.
No, I did not have a great track record with.
So any stock options you might have had in either one wouldn't.
Oh, that's an interesting story. So in Kendall Square Research, they had actually had an initial public offering. So, and I did have options. So I got, I traded in my options and got stock. And then I asked an accountant, should I sell it now or should I wait a year and get a better tax deal? Because I think long-term gains are. So he advised saving it. Unfortunately, when the company got in trouble, they put a freeze on any member of any employee from selling stock. And of course, the trouble about the stock went down. So when I finally could sell it, I got back about exactly what I paid for it. Whereas if I'd sold it right away, I think I might have gotten 10 times what I paid for it. So I learned a lesson there, and in future companies, when I got options, I cashed them in right away and didn't wait around to see what happened, because I felt like I'd been burned that way.
So what was the next company?
So interestingly enough, I was looking around for where to go next, and I had visited one company that looked like it was going to give me an offer. But then one of my former colleagues at Kendall Square told me there was this guy from this French company at this hotel and was looking for compiler engineers. So I went to this hotel, met this guy, and he said, why don't you come to France for a week and work in our company and see how you like it? And I said, oh, sure. So I went there, and it was an interesting, it was yet another supercomputer, but a different technology. And spent a week there. And at the end of the week, they said, well, would you like to come work here full time? And they said, we will pay for you and your family to move over here and put you in a hotel till you can find an apartment or something. And we will pay you, quote, an American salary, which was higher than most of the French people got, I think. So I, at that point, was married and had two very young children, one 7 and one 3. But we said, this is an opportunity of a lifetime. Let's do it. So we went, and Zvi noticed that our house was occupied by different people for a couple of years while we were gone. We had a really good time.
Yeah, they disappeared.
Hmm?
And your wife loved the idea of getting fluent in French.
Yeah, she had studied French in college, so was it. Yeah, as you say, she was fluent in French, and the kids were both at age where they learned languages very quickly. So we ended up staying there about 2 years, and we kind of toyed with the idea: should we stay, or should we go back to the States? And ultimately decided to go back to the States. So after 2 years, that's what we did. I actually continued working remotely for this company and took more or less monthly trips to France. But after a while, that got to be a bit much. Going to France for about a week every month just made me start looking elsewhere. But getting back to
what's the name of the company?
The name of the company, it was called ISTI. And that stood for something which I can't remember what, but it was actually funded by the I guess at that time they call it the Common Market, European Union or whatever. So it was a government-funded project. The best part of it, I mean, the work was okay. It was reasonably interesting, but I think from my life and my family's life, the cultural experience of living in a different place for 2 years was just amazingly good, because we learned a lot how people in France sort of have the theory of I work so I can live, not I live so I can work, which is how Americans often seem to do things. And so at the company, there were about half either people from Britain or the US, and then the other half were French. At 5 o'clock on the dot, all the French people went home. Only the Brits and the Americans stayed late, because that's what you always did in the US. But still, it was a very interesting experience. But so
now you're doing compilers for supercomputers. What's next for Chris?
What's next? Well, so I came back and decided, and I got a job. Speaking of digital equipment company, we're still around, and I got a job which is called binary translation. And the background is that Microsoft agreed to port their OS, which was called Windows NT at the time, onto this DEC chip, which was very fast. And so, since they didn't want to have to rewrite every application to run on this different architecture, we had this program, it was called FX32, which basically took a program written to run on an Intel machine, and on the fly, while you were running it, it would translate it into the instruction set of the DEC machine so it could run faster. But it was all completely invisible. You just noticed maybe the program started getting faster and faster as you used it, because more and more of it got translated. It was sort of translated on a need to be translated basis. So
Yeah.
a part of a code would get translated when you started running that part of the code. So ultimately, I was there about 3 years. Microsoft changed their mind at some point and said, no, we don't want to support your hardware. So that project kind of folded. And I went to another startup called Transmeta, which was actually a California company, Silicon Valley, but they opened an office in Massachusetts and hired a bunch of people. Probably 3 or 4 were from the group that I had been in at Digital. And they had essentially a slightly different idea, which was they built a chip which used less power, but they used the same kind of technology of compiling or translating Intel code for their computer on the fly. Unfortunately, Intel said, oh, interesting, lower power. So Intel then made a chip that ran with lower power. So the reason anyone would buy one of these Transmeta computers sort of vanished, because there was no. So once again, now I wasn't a founder of that company, so can't blame me. But anyhow, that company sort of also disappeared. And this brings us to about 2002. And then I joined a company called ATI, which did graphics chips. And turns out that graphics chips are now quite complex and they need compilers. So I was actually I managed the group that wrote compilers for these GPUs. And the interesting thing is that I mentioned a while back parallel processing, and people always said, what is the program that most benefits from parallel processing? And it turns out it's right in front of their faces, because it's the graphics. When you put a picture on the screen, actually every pixel runs a teeny little program to draw that pixel. So you have like 1024 times 1024 copies of the program running simultaneously. So
Wow.
The interesting thing is then people realize, well, wait a minute, I wonder if we can use this for computing as well. So they kind of also then went sort of back in the other direction and said, okay, we now have these really fast parallel processors we're using for graphics chips. Can we now use them for computation? And the answer is yes. And if you've been following the news of late, you probably noticed this company, NVIDIA, has done very well in the world of AI. Well, NVIDIA, when I retired from, ATI got acquired by AMD, and I retired from AMD in 2020. no, 2021, sorry. And but NVIDIA was our main competitor. They also did graphics chips. But somehow, and since I'm not there, I'm not exactly sure why, but they made out much better in the world of AI than AMD, because I think they were recently declared the most valuable company in the universe or whatever. So, but that was the same thing of using this parallel graphics type mechanism to do, in that case, AI, because AI, a lot of AI is just searching lots of data very quickly. So you can find similar, someone's asked you a question, you can go through a ton of data and find stuff that will allow you to answer that question.
I once was told that, in fact, it might have been by Bill Reducial, who we interviewed earlier, that Google was actually a big manufacturer because they made units that were optimized for search, that they made all kinds of.
Yeah, no, that's exactly.
You know anything about that?
I don't know the details, but I think you're right. Yeah, if you think about it, Google is amazing how quickly, if you type in a query, how quickly it could come up with stuff. And yeah, it would, specialized hardware probably helped out a whole bunch there. But so
Tzvi, maybe we should transition toward the ideas part on, we've talked about ideas, but toward this whole AI, I don't know that I call it a craze or a recent development. Do you see it as incremental improvement, or do you see it as entirely revolutionary? How do you look at it as someone who's been through all these different periods?
So first of all, interestingly enough, when I worked at Project Mac, I worked in the same place as the MIT AI lab. So I've been sort of following somewhat what was going on in AI for a long time. But I think the current sort of revolution in AI or whatever is mainly happening because they have the ability to store humongous amounts of data, and they have the computing power to compute or search that amazingly large amount of data. So I haven't been in that world very much, but I have talked to knowledgeable people about the current AI quote revolution. And most of the people I know who are technically savvy are sort of a little bit, they think maybe it's been overhyped a bit. And one of the examples, which has since been fixed, but early on, if you ask ChatGPT what's heavier, a ton of lead or 2 tons of feathers, it would answer they're the same because it was so used to the 1 ton of lead and one. So they've now fixed that, but it kind of makes you think.
But I think that, I don't know whether the doomsayers or futurists and so on, they sort of emphasize the idea that the machines are learning almost autonomously, and that this autonomous learning is on the one hand perhaps an aid to productivity. On the other hand, it sort of raises scary prospects.
Yeah, no, it's it's always been a theme of a background in computing. Will computers ever get to be so smart that they'll take over or whatever? There's a famous Isaac Asimov story about how the world discovers that it's collapsing, so they decide to build a giant computer to figure out what's going on. And ultimately, the giant computer uses all the resources on the entire universe or something, and everything goes black, and you think it's all over. Then suddenly, a light comes on, and someone says, "Let there be light," and there was light. But yeah, it's difficult to say how much of that is fear mongering and how much of that is real. Especially using AI in medicine and this and that. And could an AI system make a horribly bad diagnosis that any trained doctor would realize that's crazy, but the AI would, for some reason, decide that's what was going on and cause something really bad to happen to the patient? As far as I know, nothing like that's happened yet, but I do think we are in a different world, and it's going to take a little while to sort of see how things level out. Is it as big a is it as big a change as some people think it's going to be, versus is it just
there's a famous quote, you know it, by Robert Solow about computers. So his quote was, this was maybe in the 80s or early 90s, and he said, "I see computers everywhere, but in the productivity statistics," meaning that the computers supposedly are everywhere, they're doing all these things, but they haven't really made us all that much more productive than the normal rate of growth. I mean, we've had rates of growth in manufacturing and other places, so I don't know. Well, economists tend to be a little wary of the big promises.
And if you think about it, well, a couple of things. I'm not sure how related to computers being involved, but for instance, cars are much more reliable than they used to be. I mean, when I was a kid, if you had a car in the 60s that got you had 100,000 miles on it, that was like almost a death sentence if that was going to be. But these days with, a Toyota or something, people, 300,000 miles and keep going. So do they get better precision when they build things using computer-aided manufacturing? Or look at an office where, if you watch any old movies, there's, tons of people sitting around in an office typing on typewriters. Yeah. Is it faster if they can type into a word processor? I tend to think it is. I mean, fixing mistakes is a lot easier.
But people who talk about AI talk about it as more of a fundamental break. And I guess the image that they're using is this continuous learning that's autonomous almost.
Yeah.
And I don't know how to interpret that.
Yeah, I'm afraid I don't really know how to interpret. I guess
I just saw.
Go ahead.
I just saw an interview with Eric Schmidt, by the way, the former CEO of Google, who is quite expert about AI, and he said the same thing. He doesn't know what's going to ultimately what's going to come out of the autonomous learning, where the
So if an expert like him doesn't know, I don't know who would. But I guess through my entire life in computers, there are certain things that get hyped, and oh, this is it. This is the solution to everything. Everything is wonderful. But it turns out the hype is a little bit stronger than the reality of what actually comes out of. But on the other hand, when I was starting out, the idea of the internet, just amazing. B, cell phones that I can hold in my hand, something more powerful than $1 million mainframe that I used back in the 70s. I have the same computational power in my few $100 phone. That's amazing.
It is. The whole thing is like magic to be able to call up any music from
any music, or listen to a book, or you're somewhere, oh, I can't remember who invented the whatever, I'll type it into, oh yeah, that's right.
Yeah.
So I guess what I'm trying to say there is that sometimes the things that aren't hyped as much ultimately end up doing the more amazing things than some of the things that are hyped a whole lot. So
now with NVIDIA, you were talking about NVIDIA and AMD. What is the distinctive thing that has allowed NVIDIA to become almost the most valuable company?
As far as I understand it, they have we frozen? Oh no.
No.
As far as I understand it, they've built hardware especially for AI. I don't know exactly how it works, since I've been out of the business for about the 3 important years when this all came about. But I think another thing I have heard is that AI uses a lot of power, electricity, in order to process all this data all over the place. It requires a lot of electricity, which means to me that they're running a lot of processors, crunching a lot of data. So I think the sheer mass of what they do, plus, and I think NVIDIA actually somehow was directly involved with OpenAI. I read recently that maybe someone was investigating possible antitrust or something with NVIDIA and OpenAI and maybe Microsoft. So I don't know the details, but my guess is basically they did something that made their hardware especially useful for AI. Another industry that sold a lot of both NVIDIA and AMD chips was cryptocurrency, because they use lots of computation to find the next magic Bitcoin number, which has to be, I don't know, the product of 2 primes or something like that. And the more you need them, the bigger they get, and the more computation it requires to find them. There was some point, AMD had a chip that had one instruction that was very useful for crypto, for just So for a short period of time, we were clobbering NVIDIA in the crypto business, but it was just, we hadn't even put this in with crypto in mind. It just happened to be what was really useful in doing crypto analysis. So, but yeah, no, I should probably investigate more about that. Well, in fact, one of the things V put on the list of things I should talk about is what would I be doing if I hadn't retired? And it certainly sounds to me like working on hardware for AI would be an interesting thing to have been doing if I had stuck around. And I assume AMD is also doing some of that because I did keep some stock after I retired, and it has grown like possibly doubled in value in 3 years or something like that. So they're not NVIDIA, but they're not doing badly either.
Good. So Tzvi, what about, you have some additional questions or thoughts? Please.
I think we can let Chris off the hook.
Yeah, it's very interesting career.
Yeah, well, I hope I gave the flavor of what it was like going from punch cards to graphics processors, and looking back on it, it's pretty amazing how quickly it all happened. So I hope I've been useful for.
Yeah, well, you're
a real pioneer.
You're the second pioneer that we have on Ideas and Lives. I don't know whether you saw the Bill Reducial interview, but he went through a wide variety of things. Although he started as an economist and got into programming and a variety of things. So this is our high-tech component of Ideas and Lives.
History of the computer revolution.
Yeah, there you go. Very good, Steve.
And I personally want to thank you and all the other great engineers that have made my life much more comfortable, and especially in doing statistical analyses with large data sets and writing and all the other great things. And I don't take it for granted. I know maybe young people do, but somehow we have to be able to give them a little history lesson so that people will assume that
we don't want the history to disappear. Yeah.
Right.
Well, it's been fun.
Thank you very much.
It has indeed.
And we always Tzvi always leads with our ending, which is
Sei gesund.
Sei gesund, which
means
Yiddish for
be well.
Be well.
Be well,
or
as Mr. Spock would say, live well and prosper.
Ah, yes.
Yeah, all right. Thank you.
Thank you.
Okay, just